In this video, we're going to look at another way of working out volume. So let's say you've got a graph y equals x squared. We are going to rotate this along the y-axis. So rotate this 360 around the y-axis. This rotate it 360. Rotate this 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 360. And then you end up with a solid looking something like this. Okay, so we are going to look at we are going to try and work out the volume of this solid here. So in the past we would do it like this. We would sum up all the disks. Hang on. So we would sum up all the disks. So let's just look at one particular disk. Let's just look at this one particular disk here. The thickness of this disk here would be dy. So in the past we would integrate it from 0 to a. So we would integrate it from zero to a, and then we would somehow work out the area of this disk. So pi r squared, we would somehow work out this radius here, and the thickness here would be dy. So this would then give us the volume of this solid here. Okay. Now I'm assuming you understand this. We've done lots of videos on this method here. Now we're going to look at a new method, try and visualize it from a new perspective. So we are going to sum up all the, well, we're going to do it like this. Hang on, we're going to sum up. So let's just look at this one particular rectangle here. Hang on. So hang on. So we're going to sum up everything here. But let's just look at one particular rectangle here. Hang on. So when you rotate this 360, it will look something like this. Okay, and then this bit here, don't forget it has some sort of thickness along here. The thickness is actually dx. The thickness of this thing here will be dx. But the thing is, when you rotate it 360, there is an associated thickness to it, dx. When you rotate this 360, you're going to get a cylinder. If you rotate this, you're going to get a cylinder. And then if you look at this rectangle here. If you look at this rectangle here, it's going to form, when you rotate it 360, it's going to form another cylinder. The thing is, when you sum up all the cylinders, you're going to get the volume of this whole thing here. Okay, so a new way of working out volume would be us summing up all the cylinders. So if you look at this one particular rectangle here, if you rotate it 360, you're going to get a cylinder looking something like this. So you're going to get a cylinder looking something like this, because this is a cylinder. So your cylinder will look something like this. Hang on. Your cylinder will look something like this, and this here is your thickness. Your thickness is your dx. Okay, so let's just imagine you cutting this along here and then unfolding it. So we'll give you this thing here, and then if you straighten it out, it will look like a sheet of paper here. So you can imagine you getting a piece of A4 paper. If you roll it up, it will look something like this, and then if you roll it up, it will look like a cylinder. So now we've got a cylinder, so we are working backwards. If you unroll it, it will give you this sheet of paper. Well, we need to work out the volume of this cylinder here. Okay, so going back to here, if you look at one particular rectangle here, hang on. So this one particular rectangle here, it has an associated thickness to it, which is dx. Rotate it 360, it will look something like this. Okay. This here, rotate it 360, it will look something like this. And then this will have a cylinder. Now work out the volume of this cylinder. Well, you working out the volume of this cylinder, it will be this. So to sum up all the cylinders, it will be this. Summing up all the cylinders will be this. Hang on. Summing up all the cylinders, it would be you integrating from here all the way to here. And don't forget, if this is a and this is x squared, then this must be the square root of a. So you are integrating. So don't forget, you are moving along. How? Don't forget, you are moving along the x-axis here. You are moving along the x-axis here. So this here is going to be dx here, and you're integrating from 0 to square root of a, from 0 to square root of a. Okay, and then if you look at this particular rectangle here, so if you look at this one particular cylinder here, the distance around here is the circumference. Okay, so it's going to be something along the line of 2 pi r. Well, this r here, the radius of this cylinder is, well, the radius of this cylinder here. Let's start again. It's getting messy. We are going to sum up all the cylinders along here. We are moving along the x-axis. So the thickness of this thing here is dx. So hang on. So our cylinder here. So this is our cylinder here. Bear with me. So this is our cylinder here. Okay. So we're going to sum up all the cylinders. Well, us summing up all the cylinders will be us integrating from well, don't forget, it's us doing this. So we are integrating from 0 to root a. Okay. So 0 to root a being this point here, root a. Okay. And then we need to work out we need to work out the volume of this one particular cylinder. Well, for this one particular cylinder, the distance all the way around here would be 2 pi r. Well, r here is really the radius of this cylinder. Well, the radius of this cylinder is really x, because don't forget, we are moving along here. We are moving along here. So the radius at this particular point here would be x, because we are moving along here. We are moving along here. So the radius here is really x. Okay, so it would be us doing this. 2 pi x. Okay, and then we need to find out the so we've got the circumference already. So we've got the circumference already. So we've got the circumference already. We've got this length here, which is 2 pi x. And then we need to find out the height. So we need to find out the height of this cylinder. So the height of this cylinder here, would be a. That would be this level here, a. And then the height of this cylinder here. So we've got this cylinder here. Hang on. So the height of this cylinder here would be a here. A. Take away this length here. Well, this length here is x squared, so it would be this. Okay, so hang on, bear with me. So our cylinder here. So we'll remember, we're summing up all the cylinders. So that would be from 0 root a, and then it would be 2 pi this distance here to give us this distance here, the radius, is actually x, because it would be x. Okay, because we are moving along here like this, and right at this point here it will be x. So it would be this, and then we need to times the height. Well, the height of this thing would be a take away. So the height of this thing here, the height of our cylinder here would be a take away this distance here, which is x squared. Okay, and then don't forget the thickness of this thing here is dx. So this will be dx here. So this here will give us the volume of this whole solid here, because we are summing up all the cylinders. Okay, so hopefully you follow up to here. So hang on. So bear with me. So the volume is given by this. So now it's just a matter of us working out. 2 pi is a constant. Take it out. And then blah blah blah, integrate it now, the usual method. Okay, so that will then take you to this. So the volume will be given by this. Okay.